The overview detail design pattern describes interfaces that typically consist of two views: an overview that presents a collection of items along with their key attributes, and a detail view that provides details of a selected item, including many, if not all, of its attributes. This pattern is ubiquitously implemented in software interfaces and can be seen in all kinds of forms. However, while designers and developers try to create the best design that fits their general user base, a single instantiation is not enough to match the diverse needs of all users. For instance, most shopping websites will open a separate page when the user wants to view the detail of an item, but will force users to repeatedly switch views. Meanwhile, map overviews only show the price of homes to improve clarity, but omits other attributes some users may prioritize, such as the number of beds or the latest date for free cancellation. Instead of letting developers dictate how information is presented, we ask, can we make overview detail interfaces malleable? Based on our content analysis of the various overview detail interfaces in the wild, we developed interaction techniques to customize across 3 dimensions: content, composition, and layout. By providing interactions to customize along these dimensions, we enable ways for end users to expressively and easily customize their overview detail interface. We will demonstrate these interactions through a scenario of shopping for a couch in an online marketplace platform. A shopping site commonly shows details about each item, such as the price, the image, and the seller of the item. However, to see other details, one must constantly navigate back and forth between each detail view. Our key insight is that the attributes of items in the overview detail interface are not manipulable, forcing the user to excessively move between these views. We introduce fluid attributes, a novel interaction technique that makes attributes in the overview detail interface directly manipulable by the end user. And upon activating fluid attributes, the interface highlights all attributes available to manipulate. Instead of constantly switching back and forth, users can instead select the attributes they want to see and surface them to the overview, allowing them to view those attributes for every item. They can also hide unwanted attributes from the overview to reduce clutter. Surface attributes can also be used to directly sort and filter by their values. Many times, users may be interested in attributes that may be easier to describe with words. Users can query for desired attributes and ask AI to find the information from within each item. For example, users can ask, "How popular are these right now?" and AI can surface 2 attributes related to this prompt. Users can also ask to show only the linen textured couches to filter out non-linen couches. And they can even ask to show what the back of the couch looks like, which triggers AI to surface the image gallery attribute and select images that show the back of the couch. AI's operations are the same as a user's, so end users always have the control to make any adjustments afterwards. Users can also generate new attributes, such as the total cost of items, making it easier to compare true prices, including additional fees like delivery costs. Hovering over these attributes reveals a tooltip showing the sources of the attributes AI referenced. Users are also not confined by the predefined attribute names and can align attributes to become consistent to their own terms. Users can select the title and either prompt AI to simply make them consistent or specify to only show the brand name and condition. Fluid attributes also provide interactions to transform the overview into different representations, showing the most relevant ones based on the selected attributes, such as selecting attributes for axes on a scatter plot, or generating a color attribute for a color space. Since our demonstrated interaction techniques are for the overview detail design pattern, these techniques are generalizable to any instantiation of it. When looking for hotels on a map, users can select which attributes they want to see, more than just the price. If a user needs to know which emails are the most urgent to respond to, they can ask AI to fetch each email's response deadline if it has one, and then sort by the date. Live articles, such as those covering natural events, can be difficult to catch up on when joining in the middle of it, Instead of reading all of the updates, users can form a timeline view to see a bigger picture of how the event is unfolding. When ordering food on a mobile delivery app, calorie-conscious users could surface a description attribute to view each item's ingredients and calories directly on the menu. We hope that bringing malleability to the overview detail design pattern will enable end users to expressively customize their interface to address their own needs.